my name is Khalid Hamoud Muhammad Al-Sayaghi. My metric number is AF21302. I'm going to discuss the introduction. The right to building structural system is necessary to support the development of architectural works that are expanding in numbers and variety of forms. The type of truss designs, you have two types, roof trusses and bridge trusses. For roof trusses, they are typically included into the framework of industrial structures. The roof load is transferred to the truss at a joint by a set of purlins. On occasions, knee braces are used at the supporting column to maintain the frame stiffness and increase its resistance to horizontal wind forces. But for bridge trusses, it's a superstructure or a load-bearing structure. It's made up of connected triangle-shaped sections called trusses. It reacts to dynamic thrusters. The connection between the elements may experience tension or compression, occasionally both types of stresses, because it makes an optimal use of materials. Truss bridges are inexpensive to build, and they are inexpensive to build. And our objective in this project is to use this selected design, and we will research the internal forces and truss deflections. And from the finding and observation, we will talk about the truss bridge safety, and we will also make recommendation for a bridge planning and a design based on the existing bridge.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shahizan bin Amiruddin, and my metric number is DF210012. And for my part, I will explain about the design specification of the bridge. So, the overall length of the model is 16 meters, while this type of bridge is underslung truss bridges. The maximum width is 4.4 meters based on the existing bridge. The maximum height of the truss is 1.7 meters. The contact base area at each end is 4.4 meters times 4 meters. The uniform distributed load on bridge is 4,500 kilogram or 4.5 tons or 45 kilonewton per meter for overall length of bridge. Size of I-beam for all members bridge is universal column 254 times 254 times 89 millimeters. The bridge is designed as per the specifications above for several reasons. Firstly, the underslung truss bridge is proposed to enhance the existing bridge design in terms of strength, amount of deflection, and safety measures for the current bridge. The underslung was chosen to obtain the optimum design of the bridge without overdesign. Secondly, the pin and the roller supports were selected to prevent the bridge from bending during hot weather. It is because the steel bridge will be expanded and shrink depending on the weather. The clear span between the edges of the supporting abutment is 5 centimeters to reduce the amount of significant bend from occurring. Thirdly, the maximum allowable load chosen for this bridge is 4.5 tons. According to the European Union's size of heavy vehicles, the maximum load of heavy vehicle is approximately around 3 tons. So, the maximum allowable load is enough to cater the heavy vehicles passing through the bridge. When the load is applied on the bridge, deflection will occur. It can be proven that this design's deflection is 0.017536 meters or 7.536 millimeters, which is under the allowable deflection of the bridge. Fourth, the bridge is proposed with universal columns 254 times 254 times 89 millimeters to maintain the bridge resilience. In addition, the usage of the steel also can minimize the time taken to construct the bridge rather than concrete, which needs more time for curing to reach the maximum strength. So, it will affect the existing route for the villagers to wait for the concrete to reach its maximum strength. Furthermore, the usage of steel is more versatile and adaptable for the usage of villages compared to the concrete bridge, which is permanently designed for a specific project. In a cost-wise, steel is much more affordable than concrete. That's all from my part. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafiz bin Sharul, metric DF210003. Okay, today I would like to talk about the analysis and calculations of my project bridge by using software calculations. Okay, let's start talking about the calculations from software. First of all, in calculations software, Linpro is the application that we use to design the bridge. It is because this application can calculate the internal force and also the deflections of the structure bridge that we design. Before we go far in software calculations, first we should define the support reaction at the end of the structure bridge. Okay, in my project, on left side we put support pin, and the right side we put roller pin. Okay, we also put 450 kilonewton loads at the middle of the bridge, but that we want to put uniform distributed load along the bridge with the value is 30 kilonewton per meter, but we unable to put the uniform distributed load in Limpro. In Limpro, we get the support reactions at both support, which at this pin support we get 225 kilonewton. Same with the roller support, we get 225 kilonewton. So from that value, we can calculate the internal force for each member at the structure bridge. Okay, from this software, we can see that the value of internal force in blue color is a compression force, and the red color is the tension force. Okay, from this Limpro also, the maximum deflection is located at the center span, which the value is 0.017536 meters or 17 millimeters downward. Okay, so I think that's all from my part. So thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ikram bin Rashid. My card metric number is TF21403. So my part is to explain about manual calculation. So first, what I show you above is that the drawing of our design. So our design have two support, which is one pin at the joint D, one roller at the joint H, and point load at the joint D, which is 450 kilonewton. So firstly, we need to determine whether this system is stable or not. So we need to calculate total member plus total reaction equal to multiply two joints. Okay, so we got 30 members, and then we plus the 3 reaction, which is at the point at the support A we got 2 reaction, and at the support H we got 1 reaction. So it's total 3. So equal to multiply x. We got 8 joints. Okay, so after we calculate the numbers, we got at the left we got 90, and at the right we got 19. So which means this system is statically determinate and stable. So after we know this system is stable, we can calculate internal force for each members in the system. So this is how we calculate the internal force for each members in the system. So we use inspection method. So the point load at joint D we got 450 kilonewton, and the position is at the middle of the system. So we can divide two to find reaction outward at A and H. So we got 225 for each reaction outward. So after that we can calculate internal force for each members. So this the reaction internal reaction for AB is 794.12 compression. Same goes to BD, DF, and FH. And for internal reaction for AC and HG is 825.3 extension. And for internal member for CD and GED is 505.24 compression, and the internal force for member CE and EG is 1323.53 tension. So after we find this internal force in each member, we need to calculate mu for each member. So we put 1 kilonewton one unit at the joint D. So we need to calculate reaction at outward at AH. So we got 0.5 for reaction at A outward and 0.5 outward at H. After we calculate all internal force for each members in the system and mu for all members in the system, we put into the table, and we need to find each member for internal force multiplied to mu and length. So we need to find it for AB is 84008. For AC is 9445.781. So we need to total all of this, and then we can find the deflection. So the total for the uh, uh, F multiplied to mu and L for all member is 84444.52. Okay, for this system, the cross section area for the member is 115 cm cubic. So we covered it to the meters, and we get 0.0115 meter cubic. And the modular elastic for this member is 200 gigapascal, and we cover it to the Newton per meter cubic is we got 2.0 multiplied to 10 exponent 8. So this is the formula to calculate the deflection, which is F the total of all member internal force multiplied to mu and multiplied to the length divide to the area of the cross section, total area of the cross section of each members, and the modular elastic. So we calculate those things, we got deflection. So for the F, the total of F mu L is 844.52 divide to the 0.0015 multiply to 2 multiply 8 multiply 10 exponent 8, and we got the deflection, which is 0.03671 15 meters, and we cover it to the millimeter, which is we got the 36.715 millimeter. The deflection happened downward. So that's all for me. Thank you.
I will continue my part, which is discussion. An underslung bridge is a bridge that has the supporting trusses below the road surface of the bridge. For advantages, firstly, the bridge only uses steel for materials construction. Therefore, it is way more effective because it uses less materials in construction. Moreover, each member of the truss bridge is constructed with a definite purpose for truss bridge. It makes the construction and use for each truss member are perfect for the bridge. Secondly, extremely strong. The interlocking triangle structure of truss bridge greatly increase their load-bearing capacity. Compression and tension are efficiently managed by the structure by distributing the load from the roadway to its truss design. Lastly, roadways built onto the structure. The truss bridge can support its roadway on its frame. The load might be carried above the main truss structure, through the middle or below it. The versatility of the truss bridge makes it both adaptive and economical to build. Next is disadvantages. Firstly, high maintenance costs require time and money to build truss bridge. Moreover, maintaining a truss bridge can be more complicated and expensive. Therefore, it becomes quite difficult to build. Secondly, required a lot of space. The size of truss bridge is usually larger. It is because the components need to be large enough in order to bear and distribute heavy loads. Lastly, required efficient design. It is because all the trusses need to support the weight of each span over time. If not design the truss bridge properly, there could be some trusses is zero force member, which means that the trusses would just become aesthetic but are not working efficiently for the entire structure. For comparison software and manual calculation, we use Limpro as medium for software calculation. We get the deflection value for software calculation is 15.536 mm. Then we also get the deflection value for manual calculation is 36.715 mm. Technically, the manual calculation that has been calculated by our group members are correct. However, the result for both methods is not same and have different amount of value. This is because the thermal expansion alpha and moment of inertia is already included in software calculations, while the manual calculation did not have that in calculation. Next is about problem at existing bridge. The existing bridge at location already have the crack at the bridge. The cracking appears at the joint between the slab. The fence of the bridge also is not steady. Therefore, it will affect the major deflection of the structure bridge, or worst case scenario is the bridge will be collapsed if the overloads were applied on the structure. Last part in discussion is capability of proposed bridge. Maximum allowable load for the new design is 4.5 tons. So the vehicle that passing through must not exceed the maximum allowable. According to the European Union's size of heavy vehicles, the maximum load of heavy vehicles is approximately around 3 tons. So the maximum allowable load is enough to cater the heavy vehicles passing through. We using universal column UC 254 times 254 times X9 that refer to the British standard steel, which is suitable material for this proposed truss bridge due to the load that occur at that structure. And thank you.